Good afternoon, everybody. Welcome to reInvent 2025. My name is Glenn Buchholz. I'm a principal modernization and migration architect with AWS. I'm joined today with my colleague, Harleen Carr, and a very special guest, Ahmed Babars from the New York Times. He is their principal engineer. So the reason we're here today is we're going to talk about migrating from Google Cloud Platform to AWS. Now, that sounds like a little bit of adventure. I have my adventure hat on. Who here is ready for a little bit of an adventure? Show of hands. Okay, we have to talk. If, as a solutions architect, I came up to you and I said, you're going to migrate, it's going to be an adventure, does that necessarily inspire a lot of confidence in the activity? No. Today, we're going to talk about how we made it less of an adventure. So, no adventure hat. We're going to talk about cloud-to-cloud migrations in general, some of the patterns that we've observed, why AWS. We're going to talk about the thing that started the relationship between AWS and the New York Times. We're going to talk about the New York Times cloud vision. Remember, the New York Times mission is not to run the best or the fastest Kubernetes cluster. They have a mission to deliver media. And while it helps to have the best or fastest Kubernetes cluster, it's about how AWS can help them achieve that mission, and that's the vision they're going to talk about. Then we have these ideas of paved roads and blessed paths. And first we're going to talk about paved roads and how that eliminates some complexity with the container portion of the migration. Then we're going to talk about the blessed paths, and that was how we did some of the database migration. And this one is particularly interesting because it involves two dissimilar services, which I'll go into a little bit more depth to in a minute. And then after that, Ahmed will talk about some of the outcomes from the migration, and then we'll take questions. Are we ready for our non-adventure? So one of the things that I wanted to talk to you about first is migrations and cloud-to-cloud migrations. 5 years ago, when I started working for AWS, and we would talk to customers about migrations, we would talk about 5 major differentiators. And those differentiators were, 1, instant global reach. If you want to go somewhere else on the globe, you no longer had to negotiate a colo in another country or something like that. 2, AWS would reduce the undifferentiated heavy lifting that you would have to do to take care of your infrastructure. 3, on demand, paying only for what you need. 4, scalability, you can scale up and down as you need. And 5, experiment quickly. You want to experiment with something. Now, let me ask you a question. If you're coming from another CSP, are these necessarily differentiators? Probably not. Well, maybe the resiliency, and we can talk about that one because you'll see it's up on the slide right there. But for the rest of them, we have to think about the value proposition differently. And with AWS and the New York Times, there were 3 key reasons that we saw that elevated the value of using AWS. And the first was resiliency and capacity. Remember, the New York Times mission is to deliver their content, their media, to other people. And whether one person is interested in that content or 1 million people are interested in that content, they need the ability to deliver it seamlessly. And they thought that AWS was the right partner for that. 2 is partnership. Amazon has their leadership principles. And one of those leadership principles is customer obsession. And my role, and Harleen's role as solution architects, is kind of the embodiment of that. We are your partner, and we're going to try to help you get the value out of your IT spend. And we do that in a variety of different ways. We do that by making sure that your business need is fit to the right technical solution. And we do that by looking for other ways that we can be your partner that might not be technology related and we have account teams dedicated to that. And also, the unsung heroes, the technical account managers. So AWS is your partner in more than one way. We don't just provide a service where you can run things, or services where you can run things. We provide people to help you get the best value out of your IT dollar. And that can take a lot of different forms. And last, for the New York Times at least, the building blocks of AWS helped them create their cloud vision. And they saw this as the best, most efficient way to do this. We helped them create New York Times services on top of AWS services that allowed them to centralize their compute, their data, into a platform that was purpose-built for accomplishing their mission. So now that we've discussed how the value proposition is different between an on-prem to AWS migration and a cloud-to-cloud migration, let's talk about some of the blockers of cloud-to-cloud migration. Now, it can be summed up that the largest blocker is fear of the unknown. When you're working with another CSP, you're familiar with that CSP, all the quirks. You've probably spent a lot of time and education with that CSP, and change is difficult. And the fear of the unknown applies, I would say, to two different categories. These are two different things that you're going to have to approach when you're migrating from another cloud provider. The first are what I would call commodity services. These are services that look and feel the same almost no matter which service provider you're on. So, for example, a virtual machine. Most of the virtual machines, they're going to have memory. They're going to have block storage. They're going to have a number of CPUs. They're going to have probably a little play button that starts the virtual machine, and a little stop button that stops the virtual machine, or an API call that is somewhat similar. These are commodity services. And one of the ways that we alleviate the fear of the unknown for the commodity services is through education. AWS has a variety of different mechanisms that they can apply, from our training, our learning needs analysis, to immersion days, jam sessions, experience-based acceleration, and just the essay, gathering the right experts and having conversations with you about it. Additionally, the commodity services usually are shaped that way because they look very similar to on-prem services. And that means not only do we have a way to alleviate the fear of the unknown, but we have a well-trodden migration path that was established when we were first bringing the cloud into existence. So we know how to migrate SQL servers from on-prem to AWS. Well, we also have specialized knowledge to migrate managed SQL servers from other cloud providers to AWS. Tooling is pretty much the same. You use DMS or something similar, right? The same with instances and other things. Now, because the rules are a little bit different when you're going cloud to cloud, there are sometimes accelerators, things that you can do faster that you couldn't do if you were on-prem. And we have the knowledge and the expertise to help there as well. So in terms of commodity services, AWS can help get past the fear of the unknown by implementing this knowledge and these services that we already have. Now the next part is a little bit more difficult. Other cloud providers, they do have services that are specific to them. They may have an analytics suite, or they may have a database suite that's different. And as a matter of fact, one of the databases is what Harleen is going to talk about later. And there's no direct one-to-one mapping here. You can't just do a database dump and restore. It's not going to work. That service doesn't really exist on AWS. So in order to get past the fear of the unknown for the managed services, AWS's SAs, remember, we are your partner, know how to gather the expertise necessary to provide structure for these migrations and allow you to quantify the cost in both engineering effort, time, and resources in order to do this. We will go out, and if a migration SA like myself doesn't know how to do it, we will pull in the proper experts, in this case, maybe a NoSQL expert, or an analytics expert, or maybe a storage expert. And these people have real-world experiences on how these services are built from the ground up, and maybe even expertise with that service on the other cloud provider. And so it's no longer unknown. It's a path that we can chart together, and something that we can do with a level of confidence so that we can make sure that the migration is successful and within the bounds of what you've accounted for in your business plan. And lastly, in order to make sure things work, sometimes we even engage experts to do a proof of concept. On the small scale, maybe SAs like myself will do it. On the larger scale, projects have also been commissioned with professional services or partners so that you don't just have to take our word for it. And that's how we make this less of an adventure, and we remove the fear of the unknown. So with AWS, you can do these cloud-to-cloud migrations. Now, how did all of this begin with the New York Times? Well, there was a spark. And to talk about that spark, we have our distinguished guest, Amit.
Thank you, Glenn. So, Glenn has been talking about cloud migration, and now you see Amazon Connect on the slide, so you might be confused. But let me tell you how it all started. Back in 2017, it was a business problem. It wasn't a technical problem, and we weren't moving from another cloud. But the problem was, as you all might have experienced, our subscriber will call our numbers, and they will get to our IVR system. And the IVR system will try to solve the problem. But then, when the problem is not solved, they will get to a live agent. And then they have to repeat the problem again, and they validate themselves again. So the problem was how to actually cut the handle time and ensure that all context moves along from that initial conversation that they have done with the IVR to the agent, so they don't have to repeat that. So we have to transition them from a very frustrating process to a better, smooth process. And the business value here and the business proposition was like, we want to build a better customer experience. So we went in a hunt, trying to find what tools that we can implement into our stack to have something like that implemented into our CRM. And then we found Amazon Connect. It was a big transition. Now we have our telephony system, we have a lot of pieces over there, and then how to move all of that into a managed service. It was like a big ask. So we have done a proof of concept. And quickly we identified that Amazon Connect as a managed service actually is a great fit for something like that. The why, because all of the things that built or you can integrate natively with Amazon Connect. We're not talking just about telephony. We're talking about Lex, understanding the conversational. We're talking about databases, just like get the customer context, customer information. We're talking about SDKs, which for us was the actual key that we need to integrate with the CRM. So from there, now we have a good way of understanding what's good look like, and we know what managed service look like. So we start to think about what do we want to do next. And that takes us to another level where we look at our cloud vision. So what actually we are trying to achieve, if Amazon Connect as a managed service is good for that vertical business side problem, what else can we do based on AWS? So we start to think about, we want to build more compute, storage, other tooling, AI, all of that. But we don't want to focus only on these on their own on AWS. We want to focus on how to build that in a unified platform. We want to build standards. We want to have this organized into a way that we don't have to think too much about how to ship new features. So the idea and the goal here is we are not focusing on the tech itself. We are focusing on solving the business problem. And the business problem we are solving is we want to deliver news, breaking news. We want to serve games to our subscribers. So we want to focus on that. So how to shift all of that and make it make sure that we have the reliable partners to deliver this on. So from there, we know where are we going to build the stuff, but how we going to build it is interesting because back in the time, and I'm going to dive into that deeper, like we already, some of our services in AWS and some of our services on GCP, and there are other places, there are some services on-prem, but they are differentiated from each other. However, when you take a deeper look into the services, they are not completely different, like they might share some characteristics. However, because they are built across scale of teams, different teams, they don't look the same. So what we wanted to bring here is our opinionated way, our way to how we actually going to deliver on these services to our customers. So our teams have to less focus on all of the infrastructure built around, and me and my team as a developer platform team, we also less focus about how we manage all of that. So at the end of the day, we want to have our standards and good standards so we can ship this to our product engineering team, which they can focus on the differentiated features and the quality products that we want to ship to our readers. So from here, we are focusing on scale and efficiency. And I'm imagining that all of you are trying to do something similar and seeing like what does good look like for your organization. So it's probably a question that you have seen before. So we already designed where our service is going to look like or how we're going to be opinionated about it. If we take a step back and look to our product engineering team, I'm in the developer platform. I'm trying to build tooling for my engineers in other missions. And I'm going to look about, I have a business problem. Then as an engineer, I'll come with a solution. And then I will start plan it, design it, and we'll write some code, we'll ship it somewhere, and then we'll release it, we'll have a monitor. This is pretty common to any engineering teams that you have seen. So what are we trying to do with that? We're trying to centralize on that. So we're looking at what are the common patterns between all of these that we can centralize on. And we actually identified that the business problem might be unique, the idea and the plan might be unique, but not all of them. The creation of the process, the code itself will be different, but the way that you ship your code, the way you deploy your code could be the same, the way you monitor it could be the same. So what happens if we centralize all of that? And then instead of like make you think about all of these steps, you will get them out of the box. So as a platform team, our focus on building centralized CI/CD, building like observability, treating observability as a first class, not afterthought, like making sure that our deployment pipeline is always there. That gives us the opinionated way and give us exactly the boring way, but also the good boring, because like when things look the same, you don't have to think about too much. Like the process of being where I gonna deploy this is actually like what I want my service to do. So from there, we already defined the process. We actually found out like what is the problems that we are solving as a platform team, and we have the life cycle. So now to the next action, which is like how are we gonna do that? What are the technical pieces that we have to involve this process in? And when we start to look into that, one of the things that like Glenn talked about is cloud to cloud is not a copy and paste. Like there's always unknowns that you encounter through the way because there's something built with specific thought in a different cloud on these primitives. So how to move it to a different cloud or a different provider, it's always a challenge and not everything known beforehand. So the goal for us wasn't just like we want to migrate, but like we want to build a library of patterns and good standards that we can share across migrations. And from there, we decided on Kubernetes. We have been using Kubernetes for a while across multiple providers. So what if we have a shared Kubernetes architecture across the stack that like we will deploy all of our services to? So we will have the team to focus less on any infrastructure, and I will dive into the details for how this project will go through. But the other thing that was important is to focus on containerization, which makes the applications less also focused on like how to build and ship everything, but more focused on containerizing the apps themselves and have a way that we can embed this into our process and ship it to our platform. And the last thing that like we were looking into we want to have this to be parallelized across multiple teams. We don't want to do one-time project of migrating or building a single library. Like when we take like an initiative, we want to have all of the teams move to Kubernetes. We want to have all the teams to start thinking about containerization or doing something else, because we want to keep building these libraries and we want to keep automating the platform. So now we focused on that we paved the road for like, this is where we're going with containers, we already built Kubernetes, and we already focused on reliability and resiliency. So now we are trying to think through all of the steps necessary in how to get there. Like we already have the platform built, we have all of our tooling in place. Now we're gonna focus on, actually let's talk about what do we wanna do with this platform. So we have all of these steps mapped out. So we focused on building a Kubernetes setup. And the setup here is interesting, but let me tell you a couple context points about it. We are already in AWS. We have what we call AWS MA, multi-account architecture. So all of our product engineering teams have their own accounts that they can deploy their resources to. But what we came up with, so what if we start with everyone gets a cluster? That might be problematic. Now we have hundreds, maybe thousands of clusters across your organization. You can automate it, you can operationalize it, but the effort that you're gonna see from something like that, it's gonna take a toll on the team. So what if we started simpler with a shared architecture? So we have single account across multiple environments, and then we have that account focused on resiliency. So out of the box, we built like multi-region in space. And let me tell you one thing, that paid off. In the last US East 1 outage, we have our critical applications just scale into the West region, and that was good. So we definitely have some degradation, but it didn't impact us really as we would expect it otherwise. And then we focused on what we need in that shared Kubernetes. And when we look at how we would isolate it, like you're gonna see Cilium here, we use Cilium for network isolation because on like on a higher scale, like we have to make sure that each tenant from our product engineering team is isolated to our own spaces. We also focused on scaling. Carpenter here played a good role into how we scale faster, but also we can scale with different parameters to fit our needs, to fit our news, to fit our games. We're also looking at Istio, which is important for our service mesh and how traffic moved between east to west. And we look at OBA, which is how we actually gonna tell someone you are not supposed to do this automatically. We don't have to go to a team and say, hey, don't inject your URSA into that from a different account. That is done automatically. So this is the way that we set up our shared Kubernetes architecture. And that actually helped us to focus less on, as a team, as an organization, on like all of the infrastructure spun across the org, and make the team focus more into actually building the differentiated work. They focus more into like how actually they're gonna deliver different thing for the news, or like a new game, or a new recipe, or something else that matters to our subscriber. And just to summarize all of this, it's finding the common patterns between all of your steps and migrations and projects. So looking at this, applications is a good start. When I look at a lot of applications on a scale, I see like all of them doing something similar, maybe logging, maybe tracing, maybe something else that we can opt for open source, or we can build our own wrappers on top of these things. And then we look at shared configuration. Can we map these things together? So now we have done that part, and we move to containers. Now all of the applications are containerized in a way that we can ship them from one cloud to another. And actually, the process earlier started by shipping applications from being on like their own GCE or stuff like this to GKE, which is Kubernetes native, and then moves them to EKS, which helped us move through the way. So the migration here is actually giving us a toolkit that we can replicate across all of the project, and we can ensure that all of the product engineering team using the same patterns over and over from a compute layer. And that was our first step. But from here, we're gonna talk about database migration. So moving the compute is one step, moving the data is another step. So for that, I'll pass it to Harleen to start talk about the database migration.
Thank you, Ahmed. I do have a question though for you. So when we are doing the database migration and moving the applications, how much downtime can we have?
Like for a news company, for a games company, for all of the things that we do, I don't think we can afford downtime. Like I never seen a banner on the website say, sorry, we are down for maintenance, or for the game say, we cannot like give your stats right now. So I don't believe downtime is an option. Blind downtime is never an option for us. Interruptions happen all the way, but we have to plan for zero downtime when we do any migration.
Thank you. And that was the problem statement that was given to us, that the migration, the applications should not be aware that migration is happening underneath. And because New York Times is world's one of the most premier media companies, they do not have maintenance windows, as Ahmed mentioned. And it is also the mission of New York Times to make available the news and whatever is happening in the current affairs, whether there's spike in internet, anything that is happening, any implementation of any technical changes is happening, it cannot have any downtime. So not only did we have to engineer a migration, but we needed to engineer a migration where the applications would continue seamless without any issues. So it was not enough just to get there. We also needed to make sure that no one noticed. So that was a challenge that we faced when we planned for the database migration. Let's talk about NoSQL blessed path. So we did create a pattern for which we had to do the database migration from GCP Data Store to AWS DynamoDB. We had to move the application from GCP to AWS with no downtime, as Ahmed mentioned. We also had to keep the data in sync between GCP and AWS while the migration was going on. And the data that needed to be migrated between GCP Data Store to AWS DynamoDB had to be in sync and had to be migrated live. We also had to create a mechanism to do a cutover to AWS once the migration ended. And not only did we have to do the forward migration, we also had to plan for if supposing, God forbid, the migration failed, we had to have a mechanism to do the fallback back to GCP if the migration was not successful. And the best of all, the user should not be knowing about the migration and should be able to use the application while the migration is going on. So how do we get there from there? So how do we get from the state where the application is running on GCP and is using the GCP data store? How do we get from that state to the end state where the application is going to run on AWS, the data is going to be on DynamoDB, and as I remember, there is no downtime. Thanks, Ahmed. I keep on saying that because it was a very interesting problem that we had to solve. All right, so let's look at the start stage. So as I mentioned, the application is running is containerized. It is running on GCP, and it is also pumping data into data store for the persistence layer. So double write comes into the picture. That is basically the main hero of our story. So how does this work? So the application that is running on GCP has to write data to both GCP data store as well as on the AWS DynamoDB, because the idea is to maintain the current state of the database. The data has to be in sync. All the active transactions should be same both on GCP data store as well as on the AWS DynamoDB. So the application is written to PubSub, and for the PubSub, we have created one topic per table for the data store piece, and we are using PubSub to distribute the data to the new target, which is on the AWS side. We have to migrate the data reliably, and we have to do it live. And PubSub actually will guarantee the data reliability and will help us in avoiding the downtime. So what this mechanism does is it syncs the data between GCP as well as AWS, and the data is, even though the application is running on GCP, the data is being written both to GCP and AWS simultaneously to avoid any inconsistency or any discrepancy in any of the live application traffic that is coming. And on the AWS side, there is a job running which will take it to AWS Lambda, and Lambda is actually going to change or do some processing on the data that is coming from GCP, and it's actually going to create it into the format which is compatible with Amazon DynamoDB, and it's going to put the data into Amazon DynamoDB. So this was the first piece of the pie where we are actually writing double writes, but on the GCP side to make sure that the current application, the current data, and the current state of the subscriber or whatever data that is being migrated as of now is current, and there is no discrepancy and inconsistency between GCP data store as well as AWS DynamoDB. So now what do we do with the historical data? Because there is a lot of historical data which is there stored in data store on GCP because the application has been running on GCP. So there is a one-time bulk upload that is done from data store to AWS DynamoDB. And the way we do is from the GCP data store, the data is actually pushed onto BigQuery. And the reason we push it to BigQuery is because the data is stored in a binary proprietary format. And from BigQuery, there is a job that is going to pull the data and store it in the S3, which is compatible to the data that is going to fit in the DynamoDB database model that we have given it. Then what happens is we have a glue job running. Glue job will do the transformation of the data, and it's going to export the transformed data, and it's also going to push it into the Amazon S3 bucket from where the data is populated into Amazon DynamoDB. So this is how we are going to do the historical data pushback. So at this stage, you have the active data, the current data, which is already in sync between GCP data store as well as AWS DynamoDB. And at the same time, the historical data is being pushed from GCP data store into BigQuery, into S3 bucket, doing the ETL with Glue, and is going to be pushed into DynamoDB. So this historic backfill is a one-time operation. At this stage, once the historical backfill is done, the data should be in sync between GCP data store as well as AWS DynamoDB. So now we have the application which did the double writes on GCP. We have the data on both GCP and also AWS. Now how do we do the roll? How do we do the rolling cutover? Because we want to make sure the application is up and running. So what we do is we start the application on the AWS side. So whatever we did on the GCP side, we are going to replicate the same thing on the AWS side. So once the traffic is moved from GCP to AWS, the application on the AWS side is not only writing the data onto the Amazon DynamoDB, it's also going to push the data back. If you look, it goes and it does the replication of the data towards GCP, goes to BigQuery, goes to data store, making sure that the application is doing a double write, but it is doing from the AWS side to both DynamoDB as well as on the GCP data store. And the reason why we are doing this is because if for some reason there is an issue with the migration, if the migration fails, then we have a chance to roll back and we can go back to GCP and the user will not know. So this was an insurance that we kind of did for the failover if it happens. So this was the plan that we did for the rolling cutover. So now we have the application running on AWS. We have the data being synced from AWS to GCP. The current state of the data is being maintained both on AWS as well as on the GCP side. And here comes the word which I have been struggling with ever since I did that. It's
Quiesce.
quiesce. Thank you, Glenn. And he made my life difficult because he will not change the word. So, it's like, there's the word that everybody stumbles on. So this has been my nemesis, quiesce.
Quiesce.
Sorry for that. So this is like a pause period, like a peaceful time period, like a period where you let things settle down. You make sure the transactions are being processed properly on the AWS side. You make sure the migration is successful. You are doing some sanity testing. You are making sure there is no issues being reported by the users. You are making sure your KPIs, your metrics, everything is working. And so this is the QS time. And this is what we gave after the migration and the cutover was over. So now with the successful migration of the data between GCP and AWS, now it is time to decommission. So we are going to decommission the services and the workflows that were there on GCP because now the application is running and it is running on AWS and it is still running. So, all right, I'm going to hand it back to Ahmed to conclude the session and also share some of the wonderful statistics that we collected.
Thank you, Harleen. So again, the migration is complete, but like the migration in its own, it's not what are we looking for. We are actually looking for to build standards and library across the board. So that's why we found like it's really important to focus on like how to parallelize all of that effort and build that library faster enough because teams will innovate. We need them to do that indifferentiated work. So all of that work that they are going to start to do to build the quality product, we need to like make it move faster with our migration. And I'm from a developer platform mission, so my focus is engineer. So when I look at the outcome for something like that, actually happy engineering teams is my reality, is our reality. We want to make sure that the tools we are building is something that they're actually using. It helps them to build all of the stuff that they want to build. And we are going to focus on the plumbing. But when we start as a platform team focus on the plumbing, who helps us? So that's where we go to a partner like AWS and work with them on all of the things that they deliver. So we can go couple ways here. I can go build my Kubernetes cluster. I'm a very Kubernetes savvy, and then I can start like my head around etcd and how to manage it on an EC2 instance and how to keep my file, or I can run it on EKS. I can do the same for other services. So should I focus as a platform team on building the things that it matters, on building the tooling that matters for my product engineering team, or should I like actually have more managed service for AWS to work with? And this gives us also all of the nines and the availabilities that we need across regions. So we don't have to keep doing the work as a platform ourselves and then like focus more into what other innovations that we need to build for our product engineering teams. And it's not just about the platform, it's about the process, the governance, the standard, everything that we ship as a whole. So that's how the people like come together to build their services. Another thing that we want to focus on is when we know exactly how we are doing things, it becomes much easier. So one of the things that I have seen before, someone have an idea, they want to go to be a production ready, but they want to be a production ready with all of the standards baked in place. So that would take them time to test all of the processes they built. So our platform gives them all of that out of the box. So they would think about exactly their business logics, what they are shipping. Here, we're finding a reduction of 90% of service creation time. So when they start, look, I have the idea. It's ready to go to production safely with all of the standards shipped in and baked into the process and the platform itself. Another thing, when you work at scale, it's different from you focus on a couple of services. So if I have a service and I'm trying to optimize for like, I want to improve latency on that service. And then like I have to improve like 5%. Sometimes the investment doesn't make sense to focus on the small thing. Because like, sure, I will spend too much time trying to improve that on a very smaller scale. What I'm going to achieve from that, like 10 milliseconds, 50 milliseconds, depend. But like when we look at scale, and then we have many services, we look at from a platform perspective, if we have done a complete project, for example, a couple projects we done here to improve latency, one we done is cloud interconnectivity between GCP and AWS. That cuts all of the traffic, make it on the internal network, that save us actually not just latency, but also save us on the cost, because now we don't have to egress to the internet. Things like when we have to do double writes, when we have to go from AWS to GCP or vice versa, all of that is done internally on the internet, on the solutions that we build. Another thing like we may look into something like Istio or another feature in the platform when we improve on it. Just like focus on like removing one core from an application is different from removing one core from 1,000 application, from 100,000 application. The scales here matter. So all of this happens when we start focus on what is exactly are we building as a platform team for our customers. And our customers are actually a product engineering teams. So I'm building something for them on that scale with a partner that help us build that library to make it available for all of our engineers so they can focus on the problem and build more better products, and we can deliver the news at any scale, at any time. With that, thank you, and if you have any questions, let us know.
Thank you.
Really quickly, before we go to questions, one of the things that I want to point out is that when we went through the solution for the database migration, there was a step that we left out due to time. The how do we get here from here, there from here. One of the things that we left out, and this is where that partnership comes in, is data store is not an exact match to DynamoDB. So Harleen, what are some of the requirements that the New York Times gave us, like transaction rates?
Transaction rates were there. There was one other issue, how do you handle large objects? Right. Because one of the large because DynamoDB does not take in an object which is greater than 1 MB. So there were a couple of strategies that we did. One was flattening it out and just taking the fields that were actually required and that were being mapped to the DynamoDB. Second was you can always have like a pointer within DynamoDB, but the actual record is actually stored in S3 bucket for lookup. Or you can actually break it down into chunks, and all those chunks can come together with one particular key. So those were some of the technical challenges that we also faced. One of the other things was map object was not easily mappable into DynamoDB. We don't have anything called map on Dynamo.
So just so you don't think by looking at the cleanly structured diagrams and the smooth flow of the presentation that everything just happened, there was a significant amount of planning that went into this, and that is that partnership that we talked about at the beginning. So I just wanted to go under the covers a little bit and expose some of the rough edges that AWS helped smooth over during the process of this migration. All right, and now, for real this time, questions.